All right. Good morning and welcome to this class. In this lesson, this session of the class, I want to take you to this particular special SAT problem, and it's a geometric problem, a geometric progression problem. It's extracted from geometric progression. So if you think you understand geometric progression, I would like you to also put your eye here in this particular problem, and it will make sense if you understand how this problem is going to be solved. So the problem says, starting from the outer square of side x, from the figure that you can see there, a sequence of squares are made by joining the midpoints of the sides. So we are to show that the length of the sides of the squares form a GP, and also find the perimeter of the n square. Also find the perimeter of the n square. All right. Quickly wrote down a quick reminder of how geometric progression looks like. The first term, the product of the first term and the common ratio and all of that, like that. And the n term is given as this. So that's why I named them T1, T2, T3, T4, and Tn. So given that the formula of Tn is given as that. Okay, I also want you to listen to the problem very carefully. It means that the edge of the inner square meets the outer square at the central point or the midpoint or a half distance point. So that means for you to find each part of the half distance, you divide the value of the entire length by 2. Okay, so that is the concept we are going to use right now. So if I've sketched the diagram there, so using this pole here to you show the midpoint so that you can really see. So if this is the midpoint, if this is the midpoint and the entire distance is x, that means from here to this other part, or from here to this other part will be x over 2. That is, you divide the x by 2. You also divide the x here by 2. Okay. And if you look critically, you see that the hypotenuse here with the outer square form a right angle triangle. Oh, making sense. That means for us to find the length of the inner square here, we need to use the Pythagoras theorem. And the theorem said that hypotenuse square equals to opposite square plus adjacent square. I would like to use HOA next time if I'm to use this again. So, and this is the hypotenuse H, which is the length now of the inner square. So, having your, that's H, okay. So, having known your H, you have H square equals to opposites. The other two sides of the right angle here is the same value, that is x over 2 square plus x over 2 square. That will give us 2 into x over 2 square. If you open the bracket, you have 2 times x square over 4. 2 cancel 4 2 times. So that means hypotenuse square will be equal to x square all over 2. Therefore, if you take away square from the h, you find that the entire hypotenuse here is going to be equal to square root of x square all over 2, which is the same thing as square root of x square is x, and the square root of 2 is square root of 2. Therefore, we can see that the length now, which is the h length of the first inner square is given by x over square root of 2. So we are going to repeat the same thing. Now, I imagine that I'm pulling out this inner square out completely. And so I have the length now of this, the outer square for this one now become, the inner square of this one now become the outer square here. and we still have some inner squares inside the outer squares there. So we have that the length of this one here is x all over square root 2. So if you divide it by 2, you have x all over 2 root 2. You have x all over 2 root 2. That is, I divide the length here by 2, and I have this. So if you don't know how I come across that, what I simply do there is x all over square root of 2 divided by 2, which is the same thing as 2 over 1, is the same thing as x all over square root of 2 times 1 all over 2 by inverting the fraction there. So that will give us x all over 2 root 2. So that is the distance, half distance of the square, the outer square, half distance of the outer square. So that's how I got that one. So I'm going to, that means let's also do as we did before. Let's name this h. So using the same concepts, you have h squared equals to o squared plus a squared. That is hypotenuse squared equals to opposite squared plus adjacent squared. And then we have the hypotenuse that will be equals to x all over 2 root 2 all squared plus x all over 2 root 2 all squared. That will give us 2 times of x all over 2 root 2 all squared. And that will give us 2 times of x squared all over the square of 2 is 4 and the square of square root is 2. So, and 2 here will cancel 2 here, and we are left with x squared all over 4. And that means the length of the second, the third inner square, therefore length of the third inner square is x squared over 4. X squared over 4. All right. So now let's write them out. Let's see how the geometry form. Is the GP form is, we have the face length given from the problem was x, and then the second length that we obtain is x all over square root of 2. And now we've gotten the next one, which is x squared all over 4. Okay, and so on. So we've gotten the length x all over square root of 2. Is that complete? Let's go check that again. So okay, yeah, I mean it. So we have x squared here, h squared. So therefore, for you to find the value of h will be equal to the square root of x squared over 4, which is x over 2. All right. Forgive me. So that is x over 2, x over 2 here. Wow. All right, so that is the sequence form. That's the sequence form. Please, you can look at that very well. We only solve and stop at the h square. So we are looking for h. So h is going to be given as this, which is x over 2. Okay. Yes, x over 2. Let me also correct here. Its length is x over 2. Okay. So remember, I earlier stated the general form, meaning that if you check, it means that a common ratio will be given as the second term AR divided by the first term A, it will give us R, or you can say AR squared, the third term divided by the second term, which is AR, and that will still give you R, meaning that Tn uh, all over Tn minus 1, or we can say Tn plus 1 all over Tn is the ratio R. So if you take a term, like for example, T3 over T2 or T2 over T1, that should give you a common ratio. So let's see. So if I said T2 over T1 must be equals to R, and what is the value of R there? T2 is all over square root 2 divided by x over 1, which is the same thing as x all over square root of 2 times 1 all over x. And this cancel this, you have 1 all over square root of 2, which if you rationalize the denominator, you have square root of 2 all over 2. Or let's test for the the third one. We have T3 over T2 is still going to be equals to R. R can also be equals to that. So let's check out what that give. That means x all over 2 divided by x all over square root of 2, which is the same thing as um, x all over 2 times square root of 2 all over x. Of course, this cancel this, and that gives us square root of 2 all over 2, just like what we got before. So they have common ratio is the same. So of course, we can conclude that this result that we obtain is a geometric progression. So now, how do we find the last part of the problem? Now, the last part of the problem said we should find the perimeter of the nth square. How do we find the perimeter of the nth square? Now, a square, if you have a square, perimeter is the sum of all the sides here. So for example, for the first square, which the length was x, perimeter P must equals to 4 times of x. Okay. So now that the n time of the formula, the n time formula of the side, the n time formula of the side is what we must use to obtain the n time formula of the perimeter. That means the n time formula is going to be 4 times the n time formula of the nth time value, or I mean expression formula for the length of the side of the square. So the n time formula of the n square. So let's go straight to that. So the n time formula Tn, n time formula no, let me do like this for clarity's sake. The nth term formula the side of square is Tn equals to x, that is r raised to the power of n minus 1. Remember, this is first time, so okay, let me follow the formula. So, and the very first, that's ar raised power that, the very first value of the length was given as x, then the common ratio is given as, what did we get? Common ratio is given as square root of 2 over 2. So I write square root of 2 over 2 raised to the power of n minus 1, which I can also write it as x into 2 raised to the power of uh, uh, half all over 2. From indices, pull that out. There's no need for this. I can write it as uh, half minus 1, then raised to the power of n minus 1, which is the same thing as x into 2 raised to the power of half minus 1 is minus half raised to the power of n minus 1. So that means n term is equals to x raised to the power of 2, I mean x times 2 raised to the power of minus n over 2 plus n over 2. Okay, all right, so that is the n-term formula. So perimeter, therefore, perimeter of n square must be equals to 4 times of Tn. So that means 4 into x 2 raised to the power of, I can write n all over 2 first. Oh no, this place is not like that. Here is plus 1 or 1 all over 2. So I'll write this other one. I want to bring the positive value of the index first. So I'll have 1 all over 2 minus n all over 2. Okay. All right. So that is on the power. Don't also forget that 4 can be written as 2 to the power of 2. So, and then times 2 raised to the power of half minus n all over 2, then times x, So, which is the same thing as 2 raised to the power of 2, then plus half, then minus n all over 2 dot x. Okay, and we bring that down here. Perimeter that equals to 2. Let's look at that and confirm. Let's deal with that fraction at once. So r 2 plus 1 all over 2 minus n over 2, then times x. That's what we have there. Let's confirm. Yes, that's true. Okay, that's true. Okay. So don't forget I can write this 2 as 2 over 1 to complete a fractional pattern of the index of 2. So, and then we find the LCM, and the LCM is going to be 2. 2 goes into 1, 2 times 2, 4. 2 goes into 2 is 1 times 1, 1. Then, and 2 goes into 2 again is 1 times n is n. Then, times x here. X is outside. And that will give us 2 raised to the power of 5 minus n. Let's make it neat. Divided by 2 like this times x. So therefore, the perimeter, the n term value or formula of, the perimeter of the n term square is given by x times 2 raised to the power of 5 minus n divided by 2. Okay. All right. So that is where we stop for now. And you can check if x is 1, if we have 1 square, if we have 1 square, if you want to do a quick check, that means if you have n equals to 1, that means the square is 1 square. Perimeter of 1 square is going to be, that means this place is going to be 1. So we have x into 2 raised to the power of 5 minus 1 divided by 2. And then that will give us x raised to the power of 2 raised to the 4. Okay. So we have 4 divided by 2 is 2. So 2 squared is 4. That gives us 4x. That means the first, if we are dealing with the first square, yeah, which the side was x, of course, gave us 4x as the perimeter, which is true. Now you can take a look at it like this. Of course, the length of that square was given as x. So the perimeter means summing up all the sides. So it's x plus x plus x plus x. That will give us 4x. If it's for the second square, like the second square, if you want to do a quick check for that, P2 is going to be x raised to the power of 2, times 2 raised to the power of 5 minus 2 divided by 2. So, and that is going to be equals to x into 2 raised to the power of 3 all over 2. So, of course, that is, you can also write this as x into 2 raised to the power of 3, then raised to the power of half, and then you can quickly see that x into 8 raised to the power of half there, or then you can see that that is equals to square root of 8x. You can check that also. You can check if that is true by looking at the side of the second square here is given by this. That means if you draw x all over square root of 2, can draw the side of the second square was x all over square root of 2. Just add that into 4 places. 4 times that, x all over square root of 2. That will give us 4x all over square root of 2, which if we rationalize the denominator of the square root of 2, you have 4 times square root of 2 all over 2. Oh, yes. Okay, we still have x here. All right, so this cancel this. We have 2. So that gives us 2 root 2x. Or if you pull 2 inside, you will have square root of 2 squared times 2 times x, which is square root of 8x. Now, look at here. The square root of 8 is the same thing as square root of 4 times 2, then times x. Square root of 4 is 2 times square root of 2, then times x, which is 2 root 2 and x, just like before. So you can see for the second square, the perimeter is also given. That means the